So, good morning, everyone, and welcome to this lecture. Hopefully, we'll be able to finish with our circular dynamics. In this part, in the last class, we were dealing with something known as motion on a horizontal circle, and we had seen what types of problem come. Things will move on a horizontal circle, and we had to find out the centripetal force. Sometimes we had to find out the normal reaction from ground because these things were on ground. Whatever happens, whether it's a horizontal circle, motion in horizontal circle or vertical circle, what you have to always remember is that you must make three equations along three directions. You don't have to make three, you only need to have make two, because it's not a motion in three dimension that we are studying, that it is going to move along all the three dimension. It's only going to move along two dimensions. So you need only two equation. The first equation has to be made towards the center. We call the centripetal or the normal equation. The second equation you have to make it along the tangential direction. We call it the tangential equation. And the third equation, if possible, will make it perpendicular to the plane of circular motion. And remember, there is no motion happening in there. Body will stay in equilibrium. Do we understand this? We will remember this.
Yes, sir.
Okay, now the thing that we have to study is basically known as conical pendulum. So you can write the heading conical pendulum. Have you heard this term conical pendulum? Anyone? Conical pendulum. No one has heard this term conical pendulum? No idea about conical pendulum? How does it look like?
No, sir.
Its name is conical pendulum, therefore it must look like a cone. I'm looking for a good diagram that I can show it to you. And I did not find where is the diagram? Just give me a minute. I had kept the diagram here. Okay, here is the diagram. I hope you have written the heading of conical pendulum. Write the heading conical pendulum, and then we will study what is there in this diagram. So this is the diagram and the heading is conical pendulum. Conical pendulum. We'll remember these things about conical pendulum, and that would be good enough for any question that eventually comes. Now what happens in a conical pendulum is you have a pendulum. As you can see, it is tied to this point. Let us call this point as O. It is tied to this point and this pendulum rotates like this. Do you understand this?
Sir.
So it is moving in a horizontal circle. Why it is known as a conical pendulum? Because if you look at it, the shape that it makes is conical. Yes or no?
Yes, sir.
This is conical pendulum. What all things are normally given in this conical pendulum is the length L of the pendulum is given. What angle it makes with the vertical, that angle theta is given, and the mass m of the body is given. These are the three things that is normally given. Normally these three things are given to you. I mean, they can give you other things apart from these things. They might not give you mass, they might give you something else, they might not give you length, they might give you something else, they might not give you theta, they might give you something else, but this is what it is done, what it is given to you. Now you can easily find out the radius r of this circle, because when it moves in this conical pendulum, it moves in a circular path like this. Do you see the circular path? It may look like
Yes.
an it is looking like an oval shape, but it is not oval shape, it is circular shape. Just because it's on a horizontal plane, you cannot draw it. So that's why it's looking like an oval. It has a center C, as you can see. You can easily find out the radius of this circle. Yes or no?
Yes, sir.
How much will be the radius of this circle? The radius of this circle R will be equal to L sine theta. Yes or no? You understand this or not? This is
Yes,
plane trigonometry applied. The radius of this circle R will be equal to L sine theta. Yes or no?
sir.
Now, I mean, you can write, you can remember them as a point, or you can now try and make the equation of this circular path. I'll give you 2 minutes, so you can make the equation now, and whatever values you get, you can remember them. Remember, it is moving on a circular path, so it has a velocity v. Now you cannot see this velocity, so I'll draw it. This velocity will be at this point going inside the plane of the paper, and it will go like this, v. Remember, this is not upwards, it is going inside the plane of the board. Do we understand this? So the velocity,
Yes, sir.
you can assume it as v, and this velocity v is inside the plane of the paper. When the block comes at this point, its velocity will be, normally conical pendulum is a case of a uniform circular motion. The speed v and the angle theta does not change. So here the speed would be same and it will be coming out. Do we understand what I have drawn here?
Yes, sir.
So now can you make the equations of motion for this conical pendulum? You know how to make them. If you can make them, that means you understand them. I'll give you 2 minutes to do that. Yes. Anyone?
No, sir.
That means you have not not gone through what we had discussed in the previous class. This is what we had discussed in the previous class. As soon as I began this class, I also gave you there are only three equations that has to be made. You should be able to make those equations. If you can't make this equation now, that means there is no chance that you can make the equation in the examination hall. If you don't remember what I said 5 minutes before, you are definitely not going to remember anything that I said 5 minutes, 5 months, because your exam probably is up. It's after 5 months. You have to remember it. Trust your instincts. You know how to make the equation. I have told you how to make the equation. Try it. Okay, if you can't make the equation now, there is no point of giving you any more time. What are the direction in which you have to make more equation? Tell me.
Towards centers.
Towards center, so this direction. What is the force in this direction?
mv square by r.
mv square by r is not force. It is not a real force. It is just mass into centripetal acceleration. Mass into acceleration is not force. Force is a real force. That force causes acceleration. Mass into acceleration is not force. Mass into acceleration, you get acceleration from force divided by mass. You don't get force by mass multiplied by acceleration. I hope you know this, right? Force is force. mv square by r is not force. It is mass into acceleration. Mass into acceleration is not force. Tension is force. Mass into acceleration is not force. Mass into acceleration. Because you apply a force, you get an acceleration. That is why it is equal to mass into acceleration. It is not a force. You cannot call mv square by r as force. You cannot call m into a as force. That is not force. You get acceleration by force divided by mass. That is how you must think. mv square by r or m omega square r. The centripetal force. It is not a force. Whatever is the real force, it gives you the centripetal force. Yes. So, force here is T sine theta. We have resolved T into two components. If you still don't know how to resolve components, that means something is really wrong. This is T cos theta. Towards the center, the force is T sine theta. T sine theta must give it the centripetal force, which is mv square by r. Equation number 1. I don't know why it was so difficult for you to make this equation. You come to the class, bring your brain also to the class. Don't keep your brain at home and come to the class. Okay, I'm in the class, my brain is there sitting and chilling out in the fridge. T sine theta is mv square by r. This is the equation along the centripetal direction. Now along the tangential direction is into the plane of the board. No force is acting over there, so you don't have to make any equation. Then what is the third equation that you are going to make? The third equation that you are going to make, the second one here in this case, will be perpendicular to the plane of the circular motion. Circular motion is happening in the horizontal plane, so perpendicular direction is vertical. There is no motion in the vertical direction. Therefore, T cos theta, the upward force, will be equal to mg, the downward force. These were the equations that you had to make, and I'm very sad that you could not make these equations. We divide this, so you can get the value of tan theta. Tan theta will be equal to v square by rg, or you can find v as under root of rg tan theta. That is the first equation that you have to remember. If you do not understand it, remember this equation. It seems like it is very difficult for you to understand them, so remember them. V is equal to root over rg tan theta. That is the first thing they may ask you. The second thing they may ask you is, what is omega? The angular velocity. To find out the angular velocity, you just divide v by r, and that is your angular velocity. So if you divide v by r, that will be the answer that you get. G tan theta by r under root. That would be your angular velocity. If they ever ask you what is the angular velocity, this is the angular velocity. Here we have assumed that angle theta is given to you. Sometimes they might ask you the value of this tension. Now, can you tell me the value of this tension?
mg by cos theta.
Okay, that is also not wrong. T is mg by cos theta, but that was not the answer I was expecting. You can also write it as mv square by r sin theta. That was again not the answer that I was expecting. The answer that I was expecting was this one, root over mv square by r, the whole square plus mg whole square. I hope you understand how I have achieved this answer. Yes or no? Okay. So these are the things that they might ask. If you can remember them, remember them. If you can do them in the examination or nothing like it. But if you can't remember what I said 2 minutes before, there is no chance that you will remember anything that I said 5 months from now. Then keep it, remember it. I'm really very disappointed that you could not do this simple one. After doing so many of questions, you could not do this. I'm really disappointed. Anyways, leaving disappointed behind because I cannot be disappointed always. Comes the next question. I always believe that students are like cash vouchers. Sometimes the cash voucher does not work, but sometimes they get chance to redeem. And this is your chance to redeem yourself, to tell me, no, sir, we understand this and we are working on this. Chance of redemption. Your cash voucher has got one more chance. Can you click? A string breaks under a load of 50 kgs. A mass of 1 kg is attached to one end of the string, 10 meters long, and is rotated in a horizontal circle. Calculate the greatest number of revolutions that the mass can make in 1 second without breaking the string. Let's see if you can give me this answer. You have 2 minutes to do this. Do it fast. Shall I help you? Eh?
No, sir.
Okay, sir. Good, sir. This is your battle. You must fight it. I should not help you. I am the last resort. I am the SOS message. If nothing happens, then only ask me. The only way you are going to do questions in the examination hall is by you doing it now. That is the only shortcut to success in JEE.
Table.
Sir,
Yes, bacha.
sir, please, could you help us with this? We are not getting, sir.
Because you have not understood anything. You just have to apply formula, nothing else, beta.
Acha.
You just have to apply formula, nothing else. No one got this answer?
No, sir.
You are not trying hard enough. Because I've just now given you all these formula. If you cannot apply these formulas, well, I don't know what I can do. You cannot apply these formulas. What I don't know what I can do. How can I help you? I should tell you, out of this formula is what you have to put. You only have 3 formulas on board, and you cannot choose which one is correct. That's really, really bad. Anyways, I'll help you out in any case. What is the greatest number of revolutions that the mass can make? What do you mean by greatest number of revolutions? When we will have greatest number of revolution, everything is given to you. The string is 10 meters long. What is the problem? I don't understand. You've not understood the question. A string breaks under a load of 50 kg, so that is the maximum tension that the string can have. Only formulas of tension that we have is T is equal to mv square by r. That is 1. No, it is not t, it is t sine theta. Then the other formula is t cos theta is equal to mg. These are the only two formulas that you have to deal with. Which one? What do you mean by greatest number of revolutions and maximum tension? Now instead of writing this formula as mv square by r, I can write t sine theta as m omega squared r. To find out the value of m omega square r is L. M omega square r, and I already told you how much is this r. This is L sine theta. So t sine theta is equal to m omega square L sine theta. This goes away, this goes away. When t becomes maximum, m into L into omega becomes maximum. So omega maximum becomes under root of t max by m into L. T max is 500. 1 into L. This is root over 50. This is your omega. How many revolutions it can make? This is omega is radians per second. How many revolutions it can make? Number of revolutions in 1 second is frequency, my dear friends. Frequency is omega divided by 2 pi. So the answer is root over 50 divided by 2 pi. That is what they were asking. That's it.
Thank you, sir.
No, don't thank me. It's not about thanking me, but I can solve all the questions like this. That is not going to serve any purpose. If you right now, when I have told you everything about a conical pendulum, if you cannot do the question now, you will not be able to do it in the examination, or even if the same question comes. Because right now you are just noting it down from the board. Try to understand. I have no problems in solving all the questions for you. I really have no problems. I can solve them very nicely and ask them, okay, beta, now note it down. But I know that you will not understand that way. No one understands it this way. No one can clear JEE by looking at the board and writing the answers from there. No one can. I have not seen anyone do that. So, anyways, I hope that you would try better. Chalo, we'll move on to the next question. Please note this down. This is again one of the questions that has come many times. So if you can solve it, it is good. If you can't, well, you just need to remember the result, because at the end of the day, it's just like a result, because this is a standard question. So if you cannot solve it, just remember the result of what happens if something is rotating like this. So, if you can't solve it, just remember the result. Similar to the previous question. If you can't solve it, then try to remember the result. That is all that you can do. Anyways, this is the question. Seen it many times in many exams in different ways. A hemispherical ball of radius r is rotating with its axis of symmetry kept vertical. A small ball is kept in the ball. It rotates with the ball without slipping on the smooth surface. If the angle made by the radius through the ball with the vertical is alpha. Find the angular speed at which the ball is rotating. Normally, no figure is given with this, but I don't think that you have understood the question probably. So as a hint, in helping you solve this, I will also give you the figure so that looking at the figure, you can understand what is happening. Figure is normally not given with this question. They ask you what is the angular speed at which the ball is rotating. This is what they give you. The diagram is not given. I'm giving you as a hint so that you can solve the question. So this is the ball of radius r, which is rotating about the vertical axis. This is the vertical axis. You have to find alpha is given to you, r is given to you. You have to find the angular speed at which this ball is rotating. And this ball is not slipping. I'll give you 2 minutes to do this. Yes, do you have an answer?
We are doing, sir.
Should not take so much of time. The diagram is already there given. The diagram is there, should not take so much of time. The diagram is there, it should not take so much of time. So I'll solve it for you. And if I look at this diagram, which is there right in front of your eyes, and then I look at this diagram, which is here, and I'll put both the diagrams together, and you will understand. You will understand what? You understand what? Put both the diagrams together. And you will understand that both the questions are same. The only difference is this is on the left hand side, that is on the right hand side. Both the diagrams are same. Left hand side, right hand side, nothing else. So here again, what equations we need to make? One will be this. This will be n sine theta along the center. This will be n cos theta.
Yes, sir.
This was t sine theta. It was t cos theta. Exactly same questions. Nothing has changed, my dear friends. So what you got to do here, just apply equation in the centripetal direction. N sine theta is equal to mv square. They are asking you the angular velocity, so don't write mv square, right? M omega square r. Here I had written t sine theta is equal to m omega square r. Nothing has changed. The only thing that has to change is your thing that you can solve this question. The first thought that I think is coming into your head right now is that we cannot solve this question. And that is the wrong thought. That is the wrong thought that is coming into your head. Having written this equation, rest of the things should be pretty simple. You just have to eliminate n and you will end up with the equation. Remember here this r is the radius of the circle. So this r should be this small r. So I should write this as this small r. And this small r is capital R sine theta. Here also this r is L sine theta. Now you should be able to give me the answer for omega. What is the answer for omega? Yes, bacha. What is the answer for omega? What is the answer for omega?
Under root G cos alpha by R, sir.
Under root G by R cos alpha, not G cos alpha by R. How can G and cos alpha get G and cos alpha get multiplied? Cos theta is on this side and G is on this side. Anyways, small mistake that can be forgiven. But what cannot be forgiven is that you don't understand that they are seen. Now I've given you enough questions. You should be able to understand that they are same. Whether a question is of conical pendulum, most of the questions, in fact, all of the questions of horizontal circular motion where it is moving like this are going to be solved like this. And you shall see it. Have you understood this now at least?
Yes, sir.
That takes us to the next topic, which is turning of vehicles on road. How do vehicles turn on road? If it has to turn, the vehicle has to turn. It must change the direction. It must change the direction of velocity. Who is going to change the direction of velocity? Who is going to change? If the direction of velocity has to change, there must be someone, something that must provide the body, car or the vehicle with what? centripetal force or centripetal acceleration. Who is going to do that job? Three options: by friction only. Number two, by banking. The roads are banked, they are made higher than the horizontal. And the third case, which we'll not discuss because it just gets too complicated, there is no point of understanding it, is by using both. We are not going to do this. No point of doing this. So we are going to do only two cases here, where the what? The vehicle is going to turn either by using only friction or by using only banking.
Yes,
The
sir.
third is of no use. Even if I tell you, it's of no use. If the question comes, you will not have sufficient time to solve it. And the question now doesn't come. I have not seen. First one is turning by friction only. Turning on a road with friction only. Anyone has idea about this? What is going to happen here? Huh? No one has any idea. So this is the top view of a vehicle turning on road. Remember, this is a horizontal circle, so I am showing you the top view. The vehicle turns on a circle, so it has a center O, it has a radius R on which it has to turn. Now, this is the vehicle, your car. This is your vehicle or your car which is trying to turn on this road. It is definitely moving with some velocity V. Someone must provide it with something. What is that someone and what is that something? Huh?
Some force.
What?
Some force, sir.
What force, sir? Someone must provide it with something. What? Who is that someone and who is that something? Okay. Who is that someone? Who is that something? That someone is friction and that something is centripetal force. Someone must provide it with something. So friction must provide it with this frictional force which will be directed towards. What type of friction will act between the car? It's not the car, it's the wheels of the car and the road. What type of friction exists between the wheels of the car and the road?
Kinetic frictions.
Kinetic friction. Well done. Well, if it is kinetic friction, my dear friend, your car's wheel will not rotate. They will just slip like it slips on ice. Kinetic friction cannot make your car wheel rotate. It will slip. It's only static friction between the wheels of the car and your road that allows the car to grip the surface and the tire to rotate. Static friction it is. So the static friction has to provide you with the required centripetal force. What are the equations that we are going to make? Can anyone tell me? Equation number 1. Mass of the car is given, let us say, as m. What are the equations that we are going to make? Can anyone tell me? Huh? Yes.
Fs is equal to mv square by r, sir.
Chalo. The first equation is centripetal force must be coming from your static friction. Chalo. What is the next equation? This was the equation that was made in the centripetal direction. If you look at the tangential direction is like this. There is no force there. So you don't have to make any equation. Then there is a third equation which can be made in the vertical direction. Can you tell me what is that third equation, which is the second equation now? Say it. What if you say it wrongly, I will just scold you, whatever. So you are used to it.
Normal reaction is equal to mg, sir.
Hello. God has helped you here. Normal reaction is equal to mg because normal reaction is the force in the vertical and g is the force in the downward direction. Normal reaction is equal to mg. So these are the two equations that you are going to make. Now, this value of static friction is variable. It can vary from where to where? See, there was a song from a very old movie. Obviously, I was not born at that time, so you were not born. And it was a movie of the legendary Manoj Kumar, Dilip Kumar, Yusuf Saab. And there was a very famous song, छोड़ो कल की बात पुरानी, नए दौर में लिखेंगे मिलके नई कहानी, हम हिंदुस्तानी. Hey, you apply it literally. छोड़ो कल की बातें. Forget about what we have done in the last, what we have studied in the last class. Forget. कल की बात पुरानी. The last class is old. Today is a new class and we will start our journey from today. Physics does not happen that way. That is the problem with physics. Chemistry, it can happen. You don't understand electrochemistry. Yeah, forget electrochemistry. Next chapter is ionic equilibrium. Good. You don't understand ionic equilibrium. Leave it. Ionic equilibrium. The next chapter is moles. Nothing to do with ionic equilibrium. Maths also it works. I don't understand quadratic equation. Leave it. Next chapter is complex. I don't understand complex. Leave it. The next topic is trigonometry. Nothing to do. Physics doesn't happen. Problem with physics.
Sir, it's 0 to 2 pi.
Static friction is not an angle, Pagal. It's not an angle static friction. That it is between 0 and 2 pi. 0 is less than or equal to static friction. Is less than or equal to limiting friction. The maximum value of static friction is limiting
friction. Yes, sir.
What, sir? Anyways, and this value of limiting friction is fixed. Can I expect that you can tell me what is the value of this limiting friction? छोड़ो कल की बात है, कल की बात पुरानी, नए दौर में लिखेंगे मिलके नई कहानी, हम हिंदुस्तानी. The maximum value of this limiting friction is mu s multiplied by
n.
n. That is the maximum value. Now the limiting friction that we have, static friction, so we'll put the value. So this static friction, that is mv square by r, should be less than or equal to mu s into n, and n is m. M gets cancelled. That means this v is less than or equal to root over mu s into r into g. So that means your v, the velocity which you are driving the car, must be less than this value. So what is the maximum value that is possible? The maximum value that is possible is mu s into r into g. This is the maximum value by which you can drive your car and successfully turn on a circle. Most of the accidents they happen when the car is turning. Why the most of the accidents happen when car is turning? If your speed more than this value and the car and the road has no banking and it is only relying on your friction, and if the car is faster, your car will not be able to turn and you will bang boom. Similarly, when it is raining and water comes between road and the tire, the value of mu s decreases. And that is why it is said when you are driving and it is raining, drive slowly. Otherwise, boom, again you will turn and boom, you will go. Because your vehicle will not be able to turn. Vehicle does not turn by the steering wheel. Vehicle turns by friction. Steering wheel only tries to rotate the wheel. By rotating the wheel, nothing happens if there is no friction. Rotate the wheel, nothing will happen. Do. Try to do it on ice. Move on ice and try to rotate your wheel. Nothing will happen. The car will go in the one direction. Nothing will happen by doing this. Because the car is slipping. So this is the maximum speed with which you can turn your car without slipping. When the car starts to slip, the friction is kinetic, and then you are at the grace of God. When your car will stop, only God will define it. No brakes, nothing, because there is no kinetic friction. Kinetic friction cannot stop your car. It will just keep on sliding. Go. Static friction is what is going to do something for you.
Okay, sir.
A car to run successfully must have static friction. Your Ferrari will not run on ice. Just can't run on ice. Wheels will not rotate. Wheels will rotate, but car will not move. No static friction. This is the maximum value of static friction, which can allow your car to move or to turn successfully without sliding and without you banging on the person ahead. And if you look at this diagram that I have drawn, remember every concept of horizontal circular motion is exactly similar. And you look at this diagram, everything here is same. Here tension was doing the same thing, there static friction is doing the same thing. The only problem is here also tension is variable because the value of x is variable. There also it is variable because static friction is variable. The same question we did, the first question that we did in the class, this question is also same as what we are doing. Here the job of static friction is done by the normal reaction from the wall. This question is also similar, exactly similar. All these questions are exactly similar to each other. Here, the work of static friction is done by tension, and tension is fixed. And that is why you move with a fixed velocity. Do we understand this, or this has gone above and saying, bye bye, I'm going, don't worry about me?
Yeah, understand, sir.
छोड़ो कल की बातें. Done?
Sure.
Okay, so remember, this is a small question based on this. So fatafat do it and stay happy. Right? Chalo, I can put it here also. These are favorite questions for JEE. They give this question in some way or the other. What is the answer for this one?
ఎంత అంతేనా రూట్ 800 అయినా Twenty root two, sir.
Okay, 20 root 2. I hope you understand it. I'm not going to say anything. We move on to the next thing. And what is the next thing? Huh?
Sir.
Banking of roads. Turning of vehicle using banking of roads only. If you have gone on a expressway or a highway, I guess there are lots of expressways in Hyderabad and highways in Hyderabad. You will see when there is a turn, the road becomes like this. If it is a turn on the left hand side, the road becomes like this. If it is a turn on the right hand side, the road becomes like this. Have you seen this? Yes or no?
Yes, sir.
You must have seen all those in Olympics. You must have seen all those cycle races. When the cycle races are there, the track of the cycle is like this. Have you seen it? That is banking. So that the cycle can we turn because of banking. Now, how does the cycle turn because of banking? So this is the cycle or the car, whatever. Now, as soon as when the road is flat, the normal reaction is going up. But as soon as thing is gone. As soon as the road is flat, the normal reaction is going up. When I turn the road, normal reaction goes like this. What happens when normal reaction goes like this? Remember, it is turning on the road and the turn is somewhere here. Dung, 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 dung. Where? The center of the circle is somewhere here. Oh, on this circle it is turning and the radius of this circle is R. What are the equations that you can make here? I'll give you 1 minute. I always feel that students are like cash vouchers. They may fail sometimes, but you can always redeem them. Sometimes it doesn't work. Sometimes you might put the code wrong. One codes are so long. One code wrong and the cash voucher does not work. But you can still keep on trying. So I'm giving you a chance of redemption. Shawshank Redemption, one of the most highly rated movie on IMDb. This is your chance for redemption. Can you tell me, obviously, what is the max? We have to find out the value of V for which this can safely turn. What all things are given to you? Theta is given to you. Radius of the circle is given to you. And G is given to you. Can you tell me the speed at which you can turn to E only using friction, only using banking? And that is what that helps vehicles to turn when it is raining and the friction is almost absent. With repeated running of vehicles on road, the road becomes smoother and smoother. The road becoming smoother is not good because then friction goes away. Then the only thing that is helping vehicles to turn is the banking because friction is almost not there. So a smoother road is no good, my dear friend. The road is made rough knowingly so that it can give you friction. Otherwise, you are running your vehicle at the grace of God. If God helps, it runs. If God does not help, well, you meet God very soon. Yes, Shawshank Redemption. Anyone redeeming himself? Huh? So we don't need redemption. We don't need redemption. You have 1 minute to redeem yourself. I can't give you more time. Just have 1 minute to redeem yourself. If you can redeem yourself in 1 minute, you're done. This angle is theta. And geometry will tell us that this angle is also theta.
Sir, it's mu SG cos theta R.
Mu SG? What is SG? Mu S? What is mu S?
Mu s into g cos theta r.
What is mu S here? What is mu S?
Coefficient of standard friction.
Have you read the heading of the topic? Banking only. Use banking. So there's no mu S. Okay. So this is the normal reaction. I resolve it into two components. This component will be n cos theta. This component would be n sin theta. By banking the road, what we have done is we have given a component of normal to give it the required centripetal force. So, my dear friends, n sin theta becomes your mv square by r, n cos theta becomes your mg, so your tan theta becomes v square by rg, so your v becomes root over rg tan theta. That was the answer I was looking forward. Have you noted this down?
Yes, sir.
And if you look closely enough, what do you see?
They are same.
But still we can't do it. Anyways, there is no shame whenever we do something for the first time. Or why I am acting like a hero here? Because I have done this for 20 years. And every 20 years, every year, when we do this question, the students always react in this way. They don't understand that these are same. Why you don't understand it? Probably because you are seeing it for the first time. I've seen it many times, so that is why I'm, there's a saying that in Hindi we call it Anno mein Kana Raja. In English, it means deaf can become a king in a kingdom of blinds, because blinds can't see, but a deaf can see. So I am the deaf, probably you are blinds. That's why I'm the king, and that's how I'm teaching you. Okay. So this is how everything, as I told you, every question that we did was done in a similar way. Wherever there was an angle, the question becomes like this. Wherever there was no angle, the question becomes like this. This was the case where there was no angle. It was moving on a flat road. Here, friction was doing job. Flat road. Here, tension in the spring was doing the job. Flat road. Here, normal reaction was doing the job. Flat road. Here, tension in the thread or string was doing the job. Flat road. As soon as the flow road doesn't remain flat or it comes at an angle, this is how it looks like, and it looks similar in all the cases. It has to be similar because the concept remains same. Do we understand this, or this has gone above our head saying bye bye?
Yes, sir.
Okay, then there is a question that you can solve, and this is the one that you can solve. So let me know the answer. I hope now you will remember it whenever such a question comes. This should be the easiest question in mechanics. You should be able to do this. What should be the angle of banking of a circular track of radius 600 meters, which is designed for car at an average speed of 180 kilometers per hour? You can just tell me the value of tan theta. You may not be able to find out the value of the angle, but that is not required.
కొంచెం పేపర్ ఒకసారి ఇది పెట్టాము చాలా meters అంటే 600 meters అంటే తెలుసా
Yes, my dear friends, how you got to do this? It's as simple as putting the formula, getting the answer, and staying happy. Yes or no?
Yes, sir.
So tan theta is simply equal to V square by RG.
Yes.
It is in kilometer per hour, so you have to change into meter per second. And you just put the values, get the answer, and stay happy. Okay?
Yeah, that's sir.
Okay. One more thing they can ask you is this one, so you can write the next heading. Turning of cyclist or motorcyclist on road. Now, when cyclists or motorcyclists they turn on road, what do they do? If this is the road and they have to turn, normally the cyclist, now how can I draw a cycle? Normally the cyclist is like this. How do I draw a cycle? Okay, so I'll just draw the front view of the cycle, and the front view of the cycle looks like this. He is on the cycle. I think this will do. This is how the front view of the cycle is. These are his hands and whatever. This is the cycle. It looks like a cycle now. Make it like this. Okay, this looks like a cycle or a motorcycle. Normally he is like this, but when he has to turn, let's for an example, he has to turn one side. What should he do? He actually bangs his cycle. Yes or no?
Yes, sir.
If he has to turn this side, he will bang his cycle like this. So he will become here. he will come here. Do we understand what I'm trying to draw
Yes,
here?
yes, we got that.
So he will basically bend his bike at an angle theta. Now, what happens when he bangs its side? His bike like this? When he bangs his bike like this, his normal reaction becomes like this. Yes or no? Normal reaction N becomes like this. His weight still remains here, and the center of the circle is somewhere here. The radius of the circle is R. Can you tell me with what speed can he turn his bike now? With what speed can he turn his bike now? Yes? Do we have the answer? If he bangs his cycle at an angle theta, if he leans with his cycle at an angle theta, no one knows the answer? Shall I do it?
Sir, it is V equals to under root RG by tan theta.
RG by tan theta.
RG into tan theta, sir. Sorry.
So this question is still the same as what we had done. Whenever angle comes because of this, n sine theta will become mv square by r, and cos theta will again become mg. Your tan theta will become v square by rg, and the v can be rg tan theta ka root. Do we understand this? It is as simple as that. So whether you talk about this case or any of the other cases, they are exactly carbon copies of each other. Do we understand this, or this has gone above our head saying bye bye? I'm going. Don't worry about me. This is all about motion in a horizontal circle that we had to understand. Now, whenever there was horizontal circle, the weight was not giving much importance, because weight was only equal to normal reaction on flat roads, or when there was an angle, weight was equal to mg, weight was equal to n cos theta or whatever. Weight was not doing anything in horizontal circle. Where will weight do something? Where will weight do something? Weight was doing something here also, but it was not coming in the equation as such. It was not giving any type of centripetal force. Nothing was there from weight. Weight was only equal to normal reaction or n cos theta. When will weight do something in the centripetal force? When? Huh?
When the circular motion is vertical, sir.
That is the next heading that we are going to do. Motion in a vertical circle. Motion in a vertical circle. Weight is going to definitely do something. What something? Now the motion is taking place right in front of your wall, the wall that is there, right? Up till now it was happening on the horizontal floor. Now it is happening on the wall that is in front of you. Again, it has a center O, it has a radius R that cannot change. Now, what was happening when it was in horizontal circle, whether it was at this point or this point or this point or this point, weight is always same. Weight was just having one effect, that weight was giving normal reaction and cos theta on n. But here when you change the position, for example, position A, position B, position C, in between position D, and in between position E. Now, first of all, the thing is someone has to provide this block as centripetal force. If I take the example of a pendulum, let's not call it pendulum. I have a string of length L, and attached to it is a body of mass M attached to a string of length L. Now, if I make the equations at different points, in horizontal circle, the equations were same at all points because the force or centripetal force and the other forces were all same. But here they are changing, yes or no? Because of the different positions. If I make the equation at point A, what are the forces acting at point A? One is tension T. Let me call it TA. One is the weight mg. It will have a velocity VA, velocity at A. Now, if I make equations at point A, what will be the equations? At point A, what will be the equations of motion? Yes.
TA equals to mg.
Why T is equal to mg? Who is going to provide it with the centripetal force? God. God will come, okay, this is moving in a vertical motion. I have to go and give it the centripetal force. Hai na? Who is going to give this gentleman the centripetal force? Is there someone? Yes
No,
or no?
no, sir.
There's no one. Then it cannot move in a circular path. So the entire thing is okay, sir. Gone. Cut this thing out. This is of no use. Vertical motion. There is no centripetal force. No one can move in a vertical motion. Case rested. Topic khatam. Bye bye. That is definitely not the case. So the equation is like this. The net force in the towards center is TA minus mg. And that is equal to mVA square by R. R is L. That is the equation at point A. Do we understand this?
Yes, sir.
Why were we saying T is equal to mg? If T is equal to mg beta, it will not move in the circle. Do we understand this?
Yes, sir.
At point A, there is no force in the tangential direction. You don't see any force in the tangential direction. Perpendicular direction, there is no force. So F perpendicular, if you want to write, you can also write it as 0. Just to make all the three equations. This is equation at point A. Comes point B, my dear friends. This is point B, gentlemen and ladies, girls and boys. And I have drawn the free body diagram just to help you out. What are the equations at point B?
TB is equals to M VB square by L.
TB is equal to mVB square by L. Granted. F tangential, in the tangential direction, it is weight, mg. And I will call it as minus mg because it is opposite to the direction of velocity. And I'm taking the direction of velocity as positive. So tangential force is minus mg. Do we understand this?
Yes, sir.
Because it is opposite to the direction of velocity. So that gives you your tangential acceleration. What is your tangential acceleration? Minus g. The direction is downwards. Do we understand this, or this has gone above our head saying bye bye?
We understood, sir.
What about the perpendicular force? Is there any perpendicular force?
No, sir.
There is no perpendicular force. F perpendicular is 0. Can you make equations at point C, my dear friends? C, 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 C. C, 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 C. Point C.
TC plus MG equals to MVC square by L.
Chalo, we are learning something that's good. TC plus mg will be equal to mvc square by L. The force in the tangential direction is 0. Force in the perpendicular direction is also 0. Now, looking at this equation, you can understand certain important things about this. At which point do you think tension is highest? This does not require rocket science. This does not require physics. This is pure common sense.
A, sir.
Tension is highest at point A. Correct. Tension TA is highest. So where it is lowest?
C, sir.
Tension at C is lowest. At which point the string is most likely to break?
At A, sir.
At which point is the speed highest?
C, sir. Sir, A, sir.
A is highest. The speed has to be highest at the lowest point. It cannot be highest at the highest point. Law of conservation of energy also holds here. V at C is lowest. So these are the points that you should remember. Write it down. As we go from A to C, tension decreases, speed also decreases. Tension and speed are highest at point A. Tension and speed are lowest at point C. Right? I will not write it. Write it in your own language, whatever language you prefer. I will not write it because once I write it, it's my writing. So you should write it in your own handwriting. Have you written that equation? Yes or no? No, yes.
Yes.
Then we come to those middle points, that two middle points that we had seen. Not middle, they are somewhere in between A and B. This gentleman D. Normally the angle here is given with this vertical line theta. Yes, my dear friends, what will be the equation at point D? Just to help you out, I am drawing the free body diagram. This is just to help you out. Huh? What is the equation at this point? At point D, my dear friends. We are talking about at point D.
Sir, TD minus mg cos theta is equals to m VD square by L.
God has saved you. TD minus MV square. TD minus
mg cos theta.
mg cos theta. Remember, this mg has to be resolved now into two components. T minus, so this component will be mg cos theta. T minus mg cos theta is mvd square by L. Is there any equation in the tangential direction?
Yes, sir.
What?
mg sin theta minus mg sin theta.
Minus mg sin theta will be m into at or tangential force. Yes or no? From here you can get the tangential acceleration as minus g sin theta. So what you have to remember is that this tangential acceleration is continuously changing. At lowest point, the tangential acceleration is 0. At point, lowest point is point A. At lowest point, the tangential acceleration is 0. At point B, the tangential acceleration is minus mg. At point C, it is again 0. So it changes from 0 to minus mg and then again from minus mg to 0. Do we understand this? It is changing. Tangential acceleration is changing. Do we understand this?
Yes, sir.
What about the force in the perpendicular direction? Is there any force in the perpendicular direction?
No, sir.
So we'll forget that perpendicular direction and we move on to the point T. Let me call this angle as phi so that we use different terms. Theta here, phi here. Again, remember that the angle is always given with the whatever it is,
Vertical.
vertical axis. So what is the equation at point E?
TE plus mg cos theta equals to mve square by L.
PE plus now mg cos theta will be equal to m
Cos phi, sir.
cos phi, not theta. Yes. cos phi and not theta. What about the tangential acceleration?
Minus mg sin phi.
Why I'm writing is minus because it is opposite to the direction of velocity. Is there any force in the perpendicular direction? There is no force in the perpendicular direction. Do we understand this? So these are the equations that can be made from these are the equations of dynamics that can be made at the different points A, B, C, D, and E. Normally the questions are on your one side. If the points come on the other side, same equation can be made on the other side. So basically, what you have to understand is when you are going from A to C in the green path, when you are going from A to C, tension tension increases or decreases?
Decreases, sir.
Tension decreases, speed decreases. Do we understand this? Huh?
Yes, sir.
But when we are coming from C to A, then ting, ting, ting.
Increases and velocity also increases.
Tension increases, velocity also increases. Do we understand this or this is one above or saying bye bye? At point C, tension and speeds or velocity is minimum. Do we understand this?
Yes, sir.
Now this motion in a vertical circle would be studied under two headings. The first heading is this. Motion in a VC not confined to CP. What does that mean? VC means
Vertical circular motion. I think so.
VC means vertical circle. So motion in a vertical circle not confined to CP. CP means circular path. So motion in a vertical circle not confined to circular path. What does that mean actually? It means that the particle can actually leave the circular path. Particle has got the liberty. He is free. He can leave the circular path and go away. Bye bye. I'm going. Don't worry about me. He can say bye bye to the circular path and say, I'm going. And in this, the first type of circular motion is motion of a bob attached to a string. Motion of a bob attached to a string, exactly the same motion that we had studied just now. Exactly same. The problem is, not a problem. The question is why I'm calling it motion not confined to the circular path. Eh? Why I'm calling it motion not confined to the circular path. Why I'm not calling it, why I'm calling it motion not confined to a circular path.
Sir, when the velocity of the bob is not up to the required, then it may not complete the circular path.
Okay. Let us answer some questions first. Why is this bob? I have not done the bob. This is the bob, blue color. Bob of mass m, length L. Why is the bob moving on a circular path? Who is making it to move?
Velocity and centripetal force.
Who is giving it the centripetal force?
Tension and weight.
Weight is always there. Weight was also there in horizontal path, but it is not giving it the centripetal force because the center is not towards the weight. Yes or no? Center is opposite to the weight. So
Yes,
weight
sir.
is actually not. If there is no string with this bob, will you move automatically? Whee! There is no string and the bob moving like this. No, it will not happen, right? So the major thing that is giving it the centripetal force, the reason why this is moving here is because it is attached to a string and string is pulling it and string is giving it the centripetal force. Yes or no?
Yes,
It's
sir.
because of the tension in the string that this is moving on a circular path. No tension, no string, done, gone. Now, why I'm calling this one as not confined to circular path? Because if somehow the string breaks, obviously. If the string breaks, what will happen? Will it move in a circular path?
No, sir.
It will not move. It will just fall. It will follow the projectile motion and it will fall on earth. Now, equal to what happens when the string breaks? What happens? What happens to the tension in the string? It becomes, when the string breaks, what happens to the tension in the string?
Zero.
It becomes zero. Now, even without breaking, the tension in the string can become zero. When can the tension in the string become zero?
At sea.
I'm not talking about the position. I'm talking about under what condition the tension in the string becomes zero. If the string becomes slack or loose, the tension can become zero. Yes or no?
Yes, sir.
That is what I was asking. If the string breaks, if the string breaks, now if it breaks, it's a different case, or it becomes loose. Slack, tension T becomes zero. Yes or no? Yes or no?
Yes, sir.
Then the particle leaves CP. What do you mean by CP?
Circular path.
And the particle leaves the circular path. Therefore, this motion is known as motion not confined to circular path. That is why this is known as motion not confined to a circular path, because if the string breaks or if the string becomes loose, it will leave the circular path. It is not confined. Now, there can be questions based on the string breaking. There are also questions based on string becoming loose. The third sort of question that we are going to tackle first, which are questions which come in the exam, are string becoming slack. String becoming slack is the category of question that we are going to deal with. Now, the string becoming slack, where is the possibility of the string becoming slack or string becoming loose? We have got 3 points, A, B, and C.
C, sir.
Between which points? Between A and B or B and C? Between which points there is a possibility of string becoming slack?
Between B and C, sir.
The only possibility of string becoming slack is between B and C. Do we understand this? That is the next thing that you have to write. String can become loose or slack between B and C. Between any of these 2 points, the string can become slack. Do we understand this? Now, what will determine where it becomes slack? The speed at point A. The speed at the lowest point determines if the string is going to become slack or not. Yes or no? Speed at point A determines the point. If it becomes slack or it reaches point C. Now, if the string becomes slack, it is going to leave the circular path. So there is no there is no option of getting to the highest point C. So what will be the condition? Listen to my question very carefully. What would be the condition for the body to reach the highest point C?
Velocity is all your spin. B minimum.
What is the condition for the body to complete the circular path? Condition to complete circular path What is the condition to complete the circular path?
Minimum velocity.
I never use the word velocity anywhere. The condition to complete circular path would be tension at point C should be greater than or equal to 0. Condition to complete the circular path is tension at point C should be greater than or just equal to 0. Do we understand this? If the tension at the highest point is greater than 0, or even if it is just equal to 0, it will reach the highest point and then it will keep on moving in the circular path. Do we understand this?
Yes, sir.
It's not velocity getting 0. It's not velocity getting 0. Do we understand this?
Yes, sir.
So now I can write this in this way. Condition to just complete or just reach point C condition to just reach point C will be tension at C becoming equal to 0. Do we understand this? If it is greater than 0, it will obviously cross C very simply. Yes or no? Do we understand this?
Yes, sir.
Condition to just reach point C is tension becoming equal to 0. Now you go back to equation of point C, TC, MG, and this was VC. Yes or no? Yes or no?
Yes, sir.
Now you can tell me what are the equations at point C. Using this condition.
Mg is equals to MVC square by L.
Mg is equal to MVC square by L. From there you can get the value of VC as root over GL. Do we understand this?
Yes, sir.
That means we can understand this thing. Important point. To just reach point C, to just reach point C, we call it condition of looping. To just reach point C, which is condition of looping, velocity at point C should be root over GL minimum. Do we understand this? This is the minimum value. If it is more than this, it is definitely going to complete the loop. Yes or no?
Yes, sir.
Now, we know the condition of what is the condition to reach the highest point. Now from that you can find out what will be the condition at the lowest point. How will you find the condition at the lowest point? Remember, here the only force acting on the block is number 1 tension and number 2 gravity. Tension does not do any work because it is perpendicular to the motion. Yes or no?
Yes, sir.
So the only force acting on this block is one, which is gravity. Yes or no?
Yes, sir.
And gravity is a conservative force. So you can apply law of conservation of mechanical energy. You can apply lock me. Yes or no? No or yes?
Yes, sir.
That is what you got to do, my dear friends. You have to apply lock me from A to C. So apply lock me from A to C. Apply log me from A to C and get me the value of velocity at point A. We have 2 minutes to do this. Do we get the answer? Yes or no? No or yes? Well, it should not have taken us so much of time. If it has taken so much of time, that means I don't know what you're doing. So I'll do it now. So at point A, the kinetic energy is half mv square. Potential energy at the lowest point, I take it as 0. That must be equal to kinetic energy at point C, half mvc square, plus the potential energy at point A is taken as 0. So potential energy at point C becomes mg into 2L. Now I already know the value of this Vc. The value of this Vc is this. Dung 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 dung. I can put these values here and I can get the value of velocity at point A. What is the velocity at point A? Velocity at point A will be coming as root over 5GL. That is the answer that I was expecting. You have just taken too much of time to get this. Yes or no? Should not have taken so much of time. Now you can apply the equation at points A. Again, I'm giving you one chance to redeem yourself. You can apply the equation at point A and tell me the tension at point A. You can apply the tension at point equation at point A and get me the tension at point A. Yes. Are you going to do this or shall I write the answer?
No, sir, we are going to
Do it. Do it. If you do it on your own, you should be able to do it in the examination hall. Otherwise, you just have to remember these results. These are standard results. In any case, you will have to remember them.
Sir, it's 6 mg.
Very good. Tension at point A is 6 mg. So now we know the condition for completing the loop in 4 different ways. The first way is tension at the highest point should be equal to 0.
Zero.
Second way, the velocity at the highest point should be equal to
Under root GL.
third. The tension at the lowest point should be equal to
6 mg.
fourth. The speed at the lowest point should be equal to,
Under root 5GL.
do we understand this? Now, under this condition, when we have this, so I don't have the time to do this. So what I'll do is we'll go back through this in the next class and we will see different cases and then you will see a pattern. And once you understand that pattern, you should be able to solve any questions coming on this. So we will wind this up in the next class. In the next class, we will be able to wind this up. So that class is on Monday. So we'll wind this up on Monday and do some questions and get confident that we can do any question because you can always have a question on this. So that is why I'm giving you so much time. Even if you have not understood anything, I'll tell you a shortcut. If you remember one or two things, you will be able to find out everything without doing any of this. I'm just doing it for the sake of doing it so that you understand that this is how it is done. But once you understand the pattern, you should be able to do it without any help. So we'll do this in the next class with some examples and you will see I'll give you some more random examples and you will see, Just by knowing one thing, you should be able to tell me, sir, if this is this will be this will be this will be this. That should be as good as this much. So we'll see that in the next class. I hope you have understood this. If I say something, please don't take it too hard. I'm saying it for your own good, right? So work hard, and you already have the sheet. Try and do questions on that sheet, because most of the question fall in this category, and I've already told you whatever is to be told in this category. The only thing is I just tell you some pattern, something, so that will help you in solving more difficult questions. Otherwise, most of the question, 99% of the question would be solved by this only. That's it. The rest is only some patterns, nothing else. Okay, so we'll meet in the next class. I hope you will solve questions. The only way you can become good is by solving questions. There is no shortcut to success. Okay,
Okay, sir.
but only you must remember the shortcut to success is not doing everything that is put in front of you. Do it smartly is what I talk about, and that's why I send you the sheet. Work on that sheet, do nothing else. Okay, take care, have a nice day. Bye bye.
Bye, sir. Have a nice day.
God bless you.